Alright, so I have some RStudio code that's going to show you that SD squared is a very good approximation, or is a very good random variable which calculates an approximation for the standard error. And so what I'm going to do is we're going to set up 100,000 iterations of this experiment, and what we're going to do is set the sample size of for sample 1 from population 1 to be 10, and then also for population 2 we'll take a random sample of size 10. And I'm going to set these are the standard deviations for each population. I'm going to set them both to 2 right now. And now let's do an experiment where we basically calculate our random samples from normal populations. We calculate the sample means, we calculate the sample variances, and then we calculate the pooled variance estimate, which is just this sort of pooled variance calculation times 1 over n1 plus 1 over n2. Meanwhile, we're also going to calculate a Welch type variance, where we're just going to be taking S1, the sample 1 variance divided by n1, and plus the sample 2 variance divided by n2. And those are the two estimates which we're going to be comparing. Alright, so then we're going to do a histogram plot where we plot the SD squared and also SP squared times 1 over n1 plus 1 over n2. And we're going to compare these two random variables in their ability to estimate the standard error of the difference between means. Just for reference, we're going to write a vertical line in blue, and that vertical line is going to be showing the real standard error. Alright, so let's run this. Alright, so it looks like in this histogram plot, the two distributions are right on top of each other. That's why you only see one distribution. So basically, the pooled variance and the Welch style estimate of the standard error are both equivalent. Now, what happens if we make the sample size bigger for the population 2? Okay, it looks like they're basically comparable, although the variance for the purple, so the purple is the Welch style test, or the Welch style random variable which estimates the standard error, and the green is the pooled variance style estimate of the standard error. But they both look like they work right now. Now, here's where we can see where the pooled style messes up. So now I'm going to change both the sample sizes are different and the sample standard, or the population standard deviations are different. One is twice the other standard deviation. Now you're going to see whoa, look. So here's the standard error marked in blue. And here, the purple is the Welch style standard error estimation procedure. Here in green is the pooled standard error estimation procedure. And we can see that the Welch style was very good at approximating, was an unbiased estimator of the standard error, whereas the pooled variance, not so much. So we can make a generalization and say that only when the sample sizes are different and the population standard deviations are different, then you're going to have trouble using the pooled variance estimate. In summary, the Welch's t-test is a very good way of building confidence intervals. Here's a quick program I made which shows that, and you will see that here we're building a bunch of confidence intervals. So I think 10,000 of them, right? And each confidence interval is going to be a little line. And these confidence intervals, this little line here is showing the true difference in means. And these green confidence intervals are the Welch's t-test derived confidence intervals that successfully captured the true difference in means, whereas the red ones are the ones that didn't. And we can see that our confidence interval success rate was 0.9493, which is just about equal to our 1 minus alpha, 95%.